Okay, today we're going to move on to some word problems here. This will finish out the section, relatively short section, all pretty straightforward and easy. You're going to be using the Desmos for graphing on this as well. So let's bring up Desmos. Now, it says, according to data from the U.S. Bureau of the Census, the approximate population Y and millions of Chicago and Los Angeles between 1950 and 2000 are given by the following formulas, where 0 corresponds to 1950. And what year did the two cities have the same population? So what we're going to do is we're going to enter these equations in to Desmos. It should be lots of fun. I see lots of zeros here. So I have 0.000304 x to the third, then minus 0.0023 x squared plus 0.02024 x plus 3.62. I have to enter my other equation in. After I've entered these equations in, I'm going to show you how we can adjust our graph to make more sense here, because it's not going to make a ton of sense as we look at it now. Okay. So I have my two equations entered in. And now whenever I look at this graph, I don't see any points where they intersect, right? So let's go ahead and change our tools. Now it said it's from 1950 to 2000. So that should tell you that we don't need any negatives because, well, there's not negative time. But I'm going to set it at -1 anyways, just so that I have a little gap on the back side here. And I'm going to change my x to 50. Now by doing that, I can see the point where they intersect. And I can actually, if I'm this zoomed out, I can't see exactly where they intersect because they're so close. So we're just going to zoom in on this point. And if we click it, it tells us our exact point of intersection. I mean, we just can keep zooming in if we want. If I push up and down, it shows like which point is highlighted. And you can kind of see that this is on both of them. So let's go back to our question. Our question is, in what year did the two cities have the same population? So this is our point of intersection, which is 28.751. So that's 28 years after 1950. So we just do 1950 plus 28. That'll give us 1978. That's the year when the two cities had the same population. So that's fairly easy to do. The other way I could have done this was I could have subtracted the bottom equation from the top and set it equal to 0. That seems like more work to me, so I would rather just do it by setting two equations and finding the point where they intersect using the intersection method. Now what if you wanted to turn this problem into me? So if you want to turn a problem like this in, click Share Graph. It would always help if you sign in, just so that you can save this stuff. I can save this graph as question or first word problem. And 2.1 day 2. That way, whenever you share this with me, you just click copy and you would just paste it in your classroom into the comments tell me what question number it is, especially if you didn't name the file. But it just makes an easy way for you to share your work with me. And I believe now with this in this format, if I just paste this link in that you copied, now I can see that you graphed it. And you would want to give me the fact that it was 1978. But that's only if you're being asked to submit a graph. Otherwise, you don't even have to send me the graphs. All right, according to data from the U.S. Department of Education, the average cost of Y of tuition and fees at public four-year institutions in year X is approximated by this equation, where 0 corresponds to 1990. If this model continues to be accurate, during what year will tuition and fees reach 4,000? So let's go ahead and do this again. Now to get my equations back, I just click the show list. I click on the axis and it makes them go away. Now I enter in my new equation, 0.024 x to the fourth. If you don't know how to get that exponent there, I can either click A to the B, or I can just push Shift 6 to get it up there on the top. Once I have the exponent in, I just push the right arrow, and that makes it come back down. Enter that equation in. Now let's look at our graph. If I look at our graph, I'm zoomed in and I'm not seeing much of anything. So we can zoom out. Now, it should give you an idea that we're talking about being up around 4,000. So I would have to be pulling up a lot in order to get up that high. So let's just make this 5,000 for our top number. And now I'm starting to see, I see my graph at least now that I'm at 5,000. Nothing over here matters because those are negative years. I'm just going up to where it's equal to 4,000 and clicking. So it's somewhere in here between 14.2 and 14.3. How can I pinpoint that exact location? Well, one way I can do that is I can just put an equation in that's just 4,000. Let's change that, y equals 4,000. Now you're going to see that my point comes up where it's 14.228. Again, this doesn't really matter because it's 14 years after 1990, so it's still going to be in 2004. Gives you an idea of how old our book is. If it's talking about during what year will it reach 4,000. Well, 2004 was our answer, so working with some old stuff here. All right, pretty simple with word problems and with our regular problems. That's really all I have for this section. I'm going to give you an assignment to do today. Won't be super long. Watch for a bonus assignment that's about to drop. And have a good day.